Welcome to JavaScript Programming Concept 6. In this video, we're going to explore how to encapsulate a process in a concept called functions. In doing so, we're going to see how we can create and call functions. Now, if you've been following along with this video series, you're already familiar with functions that serve as event handlers. These functions contain code that gets executed when a user performs a particular action on a web page called an event listener. Now, functions can serve as so much more than just event handlers. In a math class, you may have defined the function called f of x and set it equal to a process such as x plus 2. Well, we can do something similar to that in JavaScript, where we can also define a function, provide parameters such as the variable x, and then do something with that inside of our function. In this case, we're going to do the same process of x plus 2. Now, one thing to note, in this video, we're going to explore functions that receive information, that have parameters, and also that return values. But not all functions require information, parameters, and not all functions will return values as well. Again, that's going to be left as an exploration for you to do on your own. And just to let you know, the functions we're going to be exploring are just of this particular type, ones that accept information, and then ones that return information. I just want to put that out so that you don't think that all functions require parameters and all functions return values. So once you've defined the function, how do we use it? And that's called calling a function. Now, the nice thing is, whether it's in a math class or in a JavaScript class, calling the function is the same. You write the function name, provided whatever information it needs, and then the function will be able to complete its process. Now, in this case, the process is x plus 2. And, whether it's in a math class or in a JavaScript program, we will get the value of 4 returned from our function. So let's go over to our replit and see how this is done. So one of the things I've done to kind of clearly separate the concept of defining functions and calling functions is that I've created an additional file, helper.js. This is where we're going to write our functions. Now, script.js, which is the other file we've also loaded, is where we're going to keep our main program. Now, just to kind of reiterate, if you've been following along with this video series, you're already familiar with the idea of functions. So we've created a function init that doesn't accept any parameters and won't return any information, but it is called when the web page loads. Again, that's the idea of that event listener. All right, so now that we're familiar with the structure of the replit, which is we got 2 files, one to store our functions, one to call the functions, let's actually write some functions now. So in the first scenario, we're being tasked to write a function called area. And before I do anything else, the fact that it simply says we're writing a function, I'm going to immediately put the parentheses and the curly brackets. Again, the parentheses are needed regardless of whether you have parameters or not. Regardless of whether that function receives information or not. And the curly brackets, similarly, regardless of what you do, the curly brackets identify the process that's going to be executed when this function is called. Now let's continue on with the scenario. Now you'll see here that I put the word accepts. So a function that accepts. I've adopted this convention in order to help you identify, well, what are the parameters? What are the additional pieces of information this function needs? Now, this area function needs to know the length and the width in order to calculate the area. So let's write that down. Length and width. You'll see that I've separated the parameters with a comma. Now, parameters are just variables. Eventually, they're going to get values. And again, right now, you might be feeling uncomfortable. It's like, okay, so what is the length and the width? You'll see that when we go to the other side, when we go to call the function. Let's just simply complete the function, though. You'll also notice that in the scenario, I used the word returns. That is a clear indication that this function must return something. Again, that's just a convention I've adopted to kind of help you be able to become familiar with functions that accept information and return information. Now, what are we returning? We're returning the area. Now, the area of a rectangle is simply the length multiplied by the width. And that is it. Here's our function. We've identified a process. Now let's go ahead and use that process. So in our main program, I could do a console.log call the area function, well, let's say 2, 3. So this value of 2 will be sent to the function in the place of length. So length is not going to equal to 2. The 3, because it's the second parameter, the one that's after the comma, will then get passed to the width. So width will now equal to 3. The function will perform its process, which is length times width, 2 times 3, and return that information back to where the function was called. So if all this works out perfectly, we should see the value of 6 return and then display to the console. And obviously, I mean, we can do some string interpolation in here. Let's go ahead and do that real quick. So let's say area is, and we could pull that colon of the function inside the string interpolation. Again, there's nothing wrong with that. So I got everything matched up. It should work out perfectly. All right, area 6. All right, so let's move on to our next example. Now, it is very common in a program, especially in a video game, to produce random numbers. Now, the production of random numbers in JavaScript can be rather lengthy. And if you're producing a bunch of random numbers, again, to have to repeat this process of, and I'm just going to write it down, math.random times some range plus some starting point. So again, having to write this every single time you want to produce a random number can be very tedious. So why don't we do this? Let's create a function called RND that accepts the lower and upper bound of the range. So let's say L. Actually, I'll write the full word since the scenario says it. All right, so we created our function. We have our lower and upper bound. And let's move the process inside. And now what we're going to do is we're going to return exactly that same process we identified that. And let's also do it like this. Let's do a math.floor. So that way it's an integer. And let me bring this back up. And I'm going to modify this a little bit because the starting point for us, based off our parameters, actually are lower bounded to the range. Now, what is the range? So we could create another variable called range, which is simply the upper minus the lower. All right, so what you're seeing here is that, we're able to use, quite a few mathematical operations as part of our function. We can create variables inside of our function and then simply return the value that we want. So let's go ahead and head on over to our console. And I'm going to comment out the first one just so we kind of focus on this one. And let's say console.log of RND. And let's do a random number between, let's say 0 and 5. And let's do the same thing again with a different range of 6 to, let's say, 15. Just to show you that we are able to get numbers in different ranges. So you can see here the first one was a 3, which does exist between 0 and 5, and the next one was a 9 between 6 and 15. Now just to kind of reiterate how this process works, the 0 got passed into the variable, the parameter called lower. So lower is not equal to 0 for that first example. And the 5 was fed into the upper. So upper is not equal to 5. So these parameters now have values of 0 and 5, which means when we go inside of our process, these aren't just variables. These variables have values. So this would be 5 minus 0, which is another variable, and we use that as part of our range. We would also use the plus lower to kind of adjust the starting point of the random number, and that's it. Now, just to show you the idea of using functions, again, I manually did the production of 2 random numbers, but let's say I wanted to produce 10 random numbers within the range of 1 to 10. So I could create a for loop and then put this process inside the for loop. And what this will do is this will produce me 10 random numbers within the range of 0 to 5. And there you go, you got 0, 3, 3. Interesting enough, we didn't get the value of 4. Trying to think if that's an error in my logic. But in any case, the purpose here was just simply to demonstrate to you that you can call a function within inside of a for loop, so that you could call the function repeatedly. Let's go ahead and comment this one out and explore the next one. So in the next example, we want to create a function that accepts two numbers and returns the larger of the two numbers. Now, if you're familiar with the math library, you'll know that there's already a function called max that does exactly this. But we're going to use this as a process simply to demonstrate that you can have if statements within a process. So, and hopefully you kind of picked up on that. So again, we accept two numbers. Here are two numbers, number 1 and number 2. And we're going to do an if statement that says if number 1 is greater than number 2, then we're simply going to return number 1. Because again, that's the whole process here. It returns the larger of two numbers. So we can see here that if our if statement comes back as true, that must mean that number 1 is larger. Otherwise, we're simply going to return number 2. Now, you might be thinking, well, what if they're equal? Well, if they're equal, it really doesn't matter which number I return, whether I return number 1 or number 2. But just to kind of give give number 2 a little love, we're going to return number 2 if it's not, if the first condition fails. All right, so let's give this a try. And just to kind of emphasize the idea that we can use functions in conjunction with other functions, let's create a variable n1, and let's have it be a value from 0 to 10. So again, we're using that function we just created of random numbers. And let's repeat that process for another variable, n2. And now let's do a console log. And let's do a little string interpolation with this so we can produce a little message. Say the larger of n1 and n2. So the larger number between n1 and n2 is, and let's go ahead and string interpolate here the colon of that function. So we're going to say max of n1 and n2. And that little semicolon at the end. And I think we've got everything. All right, let's give it a try. All right, so notice our function produced the numbers of 4 and 2, and it stated that 4 is the larger number. Actually, I guess I should put larger number between these two. Let's run it again. And in this case, the second number was the larger number. I'm going to run it one more time. Okay, I just want to make sure that we were able to get a larger number. So between 3 and 8 is 8. So what we're seeing here is that we were able to use one function to produce some information and then use that function to feed it to another function. All right, let's look at our next scenario. And hopefully you've picked up on that. With each of these functions, what I'm doing is I'm exploring some of the previously explored programming concepts, just to show you that functions encapsulate any process. So everything you've learned up to now can be encapsulated in a function. So let's create a function. It says repeat. So let's do that real quick. Parentheses, curly brackets. Let's go back in. Let's see this function. Oops. Choose my, not sure why that did. All right, so let's go in here. And what does it accept? It accepts a string of the text to repeat and the number of times to repeat it. So again, the scenario might be a little confusing, but what this is that, let's say I want to repeat the word hi 20 times. Well, I don't want to sit there and type hi 20 times. That's what this repeat function would do. It would accept the text and the number of times it needs to be repeated. So hopefully in the back of your mind, you think, okay, this sounds like a building example. And that's exactly what this is. We're building some text. So we're going to say for let I equals 0, I less than amount. Okay, and that's where that first piece of information comes in. So our for loop will run as many times as they requested for us to repeat the text. Let's do an I++ here. Let's do a build plus equals of the text. Oops, don't want to do it like that. If I do that, I'll actually get the words text. And I'm not going to make any other assumptions. I'm going to stick the text right next to each other. For instance, if they wanted spaces, they would provide me the space along with the text. Last thing to recall, because sometimes students, especially when the process becomes large, they'll get so excited about completing the process that they'll forget, hey, this particular function wants to return something. And what we're going to be returning is the build. All right, so let's see how this is called from our program. And let's go ahead and comment this one out. We don't need this one anymore for right now. So let's simply do a console log of, let's say, repeat. And I simply want to repeat the underscore, let's say, 20 times, which is a common thing. Sometimes I use the underscore in my console simply to create kind of like an underline. So let's see, actually that should be wide enough. And there you go. So here's my repeat of underscore 20 times. I can do a different, I could do asterisk. We'll do this. I could probably get more. I'll say 40. Hopefully it doesn't wrap around. There you go. And again, just to show you, it doesn't have to be just a single character. This will accept anything you want. So we could say hello world, and I'll put a space afterwards just so that the words don't pop up next to it. And let's do this 10 times. I'll shrink this a little bit just in case it does wrap around. Okay, so again, the repeat function could be very useful for repeating information that has to be required in your program. So one thing to realize is that you create functions to to try to make your life easier, because you could call functions over and over again. You can abstract some of the logic. So for instance, there's no need for us to do a for loop here. The work is being done inside of our function, leaving our main program to be a lot cleaner. All right, so let's explore the last function we have here, which is create a function average that accepts an array of numbers and returns the average of those numbers. So what you're seeing here is that this particular process requires an array. Now, when it comes to parameters, whether it's an integer, string, a floating point, an array, a JSON, anything that you've learned thus far, when it comes to parameter, you simply just put, actually, let me not make an assumption. Let's say put numbers. You simply just put the variable, because you got to think of it like this. That parameter is the variable that you would have declared to represent that information. Again, this might make more sense when you go through, when we see the example. So because we're doing an average, we know we're going to need to have a variable sum in order to add up the grades. We know that we're going to need to have a for loop because that's how we work with arrays. So we'll say 0, I less than. Now here's where you might be like, okay, where's the array? Remember, this variable will at some point represent an array. So you have to have that kind of like that leap of faith that the function says, okay, you need to give me an array. I will have an array, and that array is going to be stored in this parameter called numbers, which means I could do numbers.length. Now, again, just as a process that you may have explored when you were doing for loops, we're going to do a sum plus equals. And remember, numbers is our array. So I'm going to do numbers bracket 0 like you would have done in the main program. In the init function, if this whole process was contained inside of there. The only thing really missing out of here that you might feel uncomfortable is Where are these numbers? Where is this array? Again, you'll see that when we call the function. As mentioned with the previous functions, again, you might get excited that you've completed the process, but don't forget, process is not complete until you return that information that's required by the function, which in this case is not sum. It's because we're doing the average, so we're going to do sum divided by numbers dot length. All right, let's go to our script file. Let's go ahead and comment out these. And let's create a small array. Grades is equal to, let's say, 100, 90, 80, 70, and we'll leave it at that. So we have our array with our numbers inside of it. Now what we're going to do, let's do a console.log, and let's do a little string interpolation just to make it look nice. So let's say the average of, and hopefully this works out, grades is grades. Finish that string interpolation. So I've done two things here. Again, as part of an output, it's nice to kind of reiterate to the user, okay, this is the information that was accepted as part of the function, and here's the result of it. So the average of grades, hopefully it's going to print out the whole grade and not object. That was my one hesitation with that. Is now we're going to call the average function with grades. But what is grades? Notice grades is equal to that array. So this whole array will get passed into the function average in place of where numbers is. So numbers will equal to grades, and grades is the array. So that way, this is now the same array as this. All right, let's give it a try and see what happens. Oh, nice. So it actually produced the average of 190, 80. Doesn't put the word and, but that's okay because it just spit out the array itself is 85. All right, so let's go back to our presentation and review what we've done. So in this video, we explored how we can encapsulate a process. Now that process can contain pretty much anything you've learned so far. It could have mathematical operations, it could have decisions, it could have for loops, it could have arrays, it could have any combination of things. We also saw how we could take information from one function and then use it as the information for another function. Again, functions can do so much for you, from being able to clean up your main program by abstracting some of that logic away into the functions, to the ability to reuse functions over and over again inside of a for loop. So hopefully you're excited about being able to encapsulate your process in functions, and enjoy.